right, here we go. This is a fraction equals another fraction. Who knows how to solve this? What's the way we solve this?
Butterfly.
It is the butterfly method.
Yeah.
Now, this time we're doing butterfly or cross multiplying because of this. There's an equal sign there. Okay, do you remember like last 2 units when we were like, is this cross multiplying? That was adding or subtracting without an equal sign. Okay, but this has an equal. So this is the old school cross multiply and divide stuff. So let's try it. So does anyone not know how to cross multiply and divide? Or if it's been a while, here's how you do it. Ready? I like to actually like circle them. Okay, so I'm going to multiply those two. 35 times x. That's a multiplying, not a decimal. Multiply times x. It is. Equals. You got to always put an equal sign still. And then multiply the other diagonal. Looks kind of like a butterfly if you really squint at it. And, kind of. All right, so there you go. It's beautiful. Now, 20 times 7 on the right side. So on the left, what's 35 times x? 35x. And on the right side, 20 times 7. 140. Now, last step. How do I get rid of this 35? What? Okay, so 35 and x are being multiplied, so the opposite is to divide. Okay, so whenever you see 35x like this, you know they're being multiplied. The opposite is to divide by 35. What's 140 divided by 35? Don't do that. Okay, you don't need to say random words. All right, 140 divided by 35. What do we get? Okay, that is a random number that you do not need to say. Thank you. So 140 divided by 35 is what? Okay, 4. Thank you. Do y'all remember doing that in your lifetime? Hopefully. Cross multiply and divide. Okay, now, I know that we keep having to do this stuff, but we have to keep moving along, trucking along. The Friday we get back from spring break, we have to test on this stuff. It is what it is. Every other Algebra 2 class is doing it, okay? So we're trying to make sure we get as much in before the break. That way, when we get back from the break, we're just kind of making sure we understand it. That way, that Friday we can be good on this. So we got to do some more notes. Now here's the deal. Thursday and Friday, next 2 days, no notes, okay? You just work on your assignments. Cool? For real, for real. But we got to do this, so let me pass it up. We got brand new notes. Listen.
They just posted on like Google Plus. Yeah, but
It's a cool song. It's just older. Bad stuff. All right, here we go. Okay, 8.4. We're going to solve some rational equations. Here we go. Just like our warm-up. How do I solve this? I butterfly it. All right. So 2 times x, 3 times 5. So it's going to look like this. Right? So 2 times x, 3 times 5. What is 2 times x?
2x.
2x. What is 3 times 5? 15. And then my last step, 2x is 2 times x, right? So what's the opposite of that? So I'm asking you, how do I get x by itself? So how do I get rid of this 2? divide by 2, okay? So when I divide by 2, 15 over 2 is the reduced fraction, but you could press Control-Enter to get the decimal. Okay? So let's do that. 15 over 2 gives me 7.5 yas. Nas or yas? Okay. Now, that's example 1. That's easy. And then, of course, we're going to make it extremely harder in the next couple examples. Y'all ready for that? All right. Here we go. Look at that. Okay. Okay. Here we go. Example 2. Well, I didn't think that would be on there. Okay, 1 second. Let me get rid of this. Go away. Don't need that. Come back here. Open it up. Go down here. Open it up. Here we go. All right, y'all ready for example 2? Here we go. If you see a fraction equal to another fraction, once again, we're going to cross multiply or butterfly method. Ready? So this whole side 4 is going to be times x plus 1, and this whole side 3 is going to be times x minus 2. Okay, so it's going to look like this. 4 times x plus 1 looks like this. 3 times x minus 2 looks like this. And then we must do what? So what do you do with a number in front of a parentheses? What's that thing called? You are multiplying. What's the thing called when you
Term.
what?
It starts with R, right?
No. What do you call it when you take a number and you distribute? Did you think of that all by yourself? Sheesh. All right, so we are now going to distribute that 4. So what is 4 times x and what's 4 times 1? So 4 times x is 4x, 4 times 1 is 4. And then you do the same thing on the other side. You distribute 3 times x, 3 times negative 2. So 3 times x is 3x. 3 times negative 2, negative 6. Now, it's been a while since we've solved a multivariable, or sorry, one variable, but with variable on both sides equation. So do y'all remember how to solve this? What do I do when x is on both sides? No. Okay, when x is on both sides, we know x cannot be on both sides. We need to get rid of one of those x's, right? Who wants to get rid of an x? All right, so we are going to get rid of the smaller x, which is 3x. Does that make sense? Get rid of the smaller x whenever you get to this situation. How do I get rid of a positive term? Negative, or subtract 3x, right? That makes sense? When you have an x on both sides, you get rid of the smaller x?
Yeah.
All right, so we're going to subtract 3x on both sides. 4x minus 3x gives me straight up 1x. Bring down the 4, bring down the negative 6. And I really hope you can solve a one-step equation. So much, and you know that because I tell you every dang day. So, how do I get rid of this plus 4? The opposite is minus, or subtract 4 on both sides.
Is it negative 10?
Oh yeah, negative 6 minus 4 is negative 10. Cool. Can you get that on your own? Question? Negative 6 minus 4.
I was thinking.
Yeah, not 2. What's up? You're going to miss like when it gets really hard. Last time you took like 5 years, so. All right, so example 3, you ready? All right, what do I do? When they're equal, what have we done the last 2 times? What's it called? Cross multiply and divide. All right. So 3 times 4x plus 5, 9 times x plus 1. Okay. So again, this times this times this. Look at that. Look at that. Now, what do I do with the number outside the parentheses? What's that called again? Distribution. You distribute the 3 and you distribute the 9. You're multiplying 3 times 4x, 3 times 5, 9 times x, 9 times 1. So hopefully you know 3 times 4x is 12x, 3 times 5 is 15, 9 times x is 9x, 9 times 1 is 9. You get this situation.
One number. Then we divide or
Well, let's remember, like on the last one, when x is on both sides of the equation, what do I need to do? You need to get rid of the smaller x. So what's the smaller x? 9x. How do I get rid of a positive 9x? Minus 9x on both sides is correct. Now, I think they're going to do 2 steps at once. Yeah. And so what they're doing is they're doing 2 steps at once. They're getting rid of the 15 on the left by subtracting 15 on both sides. 9 minus 15 gives you negative 6. Okay? Yeah, sorry. So they did 2 steps all at once. So they got rid of the 9x on the right, subtracting it. They got rid of the 15 on the left by subtracting it. You can do multiple steps at once. I don't recommend it because it can goof you up. So 3x equals negative 6. How do I get rid of this 3? How do you get rid of this 3? How do you get rid of the 3? Divide by 3. And what's negative 6 divided by 3? Negative 2 when you're dividing. Hey, how do you have 1 in when I just literally went over there and told you to have 0? I know you know the difference between 0 and 1. All right. Is everyone good with example 3? Let's do example 4. No? Yeah? No? Yeah? No? All right, who's still doing example 4? Example 3, sorry.
x by x, x. That's a good wrapper, huh? What? Good wrapper.
All right, once we all have it down, we'll go to example 4. Yes, you can. Just do this.
How do you do that?
Do the hand binoculars. Then you really focus, because that's all you'll see, you know? And you'll look cool. All right. Oh, or you can do the... All right. Now, example 4. I hope by now you know that we need to cross, multiply, and divide because there's an equal sign, right? Are you though? So x times x is what? X times x, and on the left side, 3 times 12. Okay. So check it out. X times x is not 2x. That's when you're adding. Okay. When you multiply x times x, you should get x squared. X times x is x squared. Okay.
Let me get to the assignment right after this one.
Of course, we're not even halfway done with these notes, so don't even think about that yet. Now, I need to solve this. How do I get rid of the squared on the x squared? What's the opposite of squared? What? Yeah, what's it called? Square Root. Now remember that? Square and square root are opposites.
I do.
All right, so everybody, when you have a square, you're going to do the square root, which looks like this. So the square root and the square cancel out. Here's the question. What's the square root of 36? Yeah, what times itself is 36? It is 6. Okay, cool. But it's not just 6.
What? 6.
It's also negative 6. So, well, you tell me, what's negative 6 times negative 6? Positive 36.
Oh, why?
Because a negative times a negative is positive.
Yeah.
So whenever you do a square root, there's really always two answers. This weird little symbol right here means plus 6 and minus 6. Whenever you do a square root, there's two answers, a positive and a negative. For sure, for sure. For sure. Okay, steps at the bottom. Does everyone have this down? All right, write these down real quick and then flip it over. To solve a rational equation, you must multiply across the equal sign and isolate the variable. Right? Get that down on the very bottom there. All the way at the bottom.
I gave it 5.10, right?
I have no idea. All right, two more examples. By the way, the examples are misnumbered on the paper there. So we just finished example 4, and when you flip it over, it says example 4. Crazy. Okay. So you want to fix those on the back. That's actually example 5 and example 6. Okay. All right, here we go. Is everyone on the back? All right. This is where it can get confusing. So I want everyone to focus. Give me like 5 to 10 minutes more of your time. Ready? All right. So check it out. Here's an example of adding fractions in an equation. Okay. Is the top correct? 2 plus 3 equals 5. Okay. So the same thing would be true even if it was all divided by 4. Okay. So here's kind of the general idea. If you have fractions in an equation and all the bottom denominators are the same, you basically just eliminate the bottom. Okay? So that's what it says here. The equation has multiple ratios. Find the common denominator. Change the fractions so that they all have the same denominator. Eliminate the denominators, and then you can solve for x. I'm going to show you how this works right here, right now, on example 5. So is everyone on what should be labeled as example 5? Your paper says 4, but it seems to be 5, right? Okay, there we go. This example. Can we add or equal these fractions? Yes. Are all the denominators the same? No. Okay, so 3 is different than x, and it's different than 3x, right? Yeah. Do you remember how we did this a few days ago? They need to match. They need to have the same denominator, right? So we need to find the LCD, the least common denominator. So here's my question. What does 3x and 3x all go into? Not 3.
X.
Not x.
6.
Not 6.
9.
Not 9. It's not a single number. So,
42.
okay, I already told you to stop that. Now, think about it again. What does 3 and x and 3x all go into? 3x. Thank you. Doesn't 3 go into 3x? It does. Doesn't x go into 3x? And 3x is 3x. Okay, so it works out that way. Off to the side, go ahead and put the least common denominator, the LCD, is 3x. So I need to make each fraction's bottom look like a 3x. So what would I have to multiply the first one by to get 3x? It's already a 3, so I need the x, okay? So this first fraction needs to be multiplied by x. Looks like this. Okay? So if you want to, you can rewrite it so you have some room to put these multipliers next to it.
When you multiply by x, doesn't it just become For 5x, but you multiply by 3.
Did you say 5?
Or, yeah, 5.
Okay, 5 over x. So yeah, this fraction, to get 3x, multiplies the bottom by what? 3. So this second fraction needs to be multiplied by 3.
Okay.
Do you see how now each denominator has a 3 and an x? They're all going to match, right? The numerators on top. So since that's already 3x in the bottom, you don't touch it. Okay. Now, what did I say on the last slide? If the bottoms are all the same, you can scratch them all out. Get rid of the bottom of the fraction, and we just care about the top of the fraction, right? Right? You, right? Put that away. You don't need it. You don't need it in your life, ever. All right, check it out. So 2 times x is what? 2 times x is what? 2x. 3 times 5 is what? 3 times 5 is what? 15. All right. So now, since the bottom, since the bottom is 3x, scratch it out. All I care about is the top now, okay? So 2x plus 15 equals 4. Yas? Can I get a yas? Now, can you solve this two-step equation? What do I get rid of first on this side? Not 2x.
15.
Not 4.
15.
The loner on the side of x is 15. How do I get rid of a positive 15?
Negative.
Negative, or subtract 15 on both sides. Both sides. What is 4 minus 15?
Negative 11.
Negative 11 is correct. Last step. How do I get rid of that 2?
What does it mean? That's you.
Not you. You. All right, but 2 and x are being multiplied, so the opposite of multiplying should be dividing, right? So to get rid of that, we divide by 2 and you get.
Oh. No. Why do you take her phone with all this?
I wasn't
True.
even on
You
it.
don't know that shit all the time.
I wasn't on it. If it turns on and it was
Hand it over. Throw it. Throw it.
You must be out of your mind. I'm not throwing my phone back.
No. To get rid of that 2, we said divide by 2. What is negative 11 divided by 2? If you hit, right. So if you press Control Enter, you get the decimal answer. That's good. Okay, one more example. The actual example 6. So yours says 5. It is mild. It's kind of mid.
Mild. Alright.
It's like, buffalo wings sauce, but not like Carolina Reaper.
Is this one of those things that we have to find the common denominator?
Yes.
After this. Okay, hold on. Ready for your last example? Here we go. I see a couple things here. First of all, what is that?
That's a minus.
Okay, this is a minus sign, so I'm going to have to remember. Don't know what to do with that.
Make it an addition and then put a minus.
Okay, so turn that minus into a plus, kind of like turn that frown upside down. And then the minus, it's still there, but it moves over here to the 6. Okay, does everyone see that? We are making it an addition problem, but the 6 now is negative, right? Hey, you, look. Now there's a big blank underneath the middle term. Here's why, and I want everyone look at me. Get serious here. Anytime you see a trinomial like this, think of 5.0. You need to factor that thing. Y'all remember factoring trinomials like 2 assignments ago? Remember, you have to figure out what multiplies to make this and adds up to make this. Yes? Okay. Let's think about it. What is the only factor of 3? What times what? 1 times 3, and also technically negative 1 and negative 3. But what adds up to make a positive 4? 1 and 3, right? So your factors are going to look like this: x plus 1 and x plus 3. Do you see how that works? I have a trinomial. I figure out the factors of 3 that add up to make 4. It's 1 and 3. I put them right here and right here. You got to be able to factor, right? Thought you would flinch. All right, so now, this is very important. Now, what is the least common denominator of all three of these fractions? So this one is x plus 3. This one is x plus 1 and x plus 3. This is x plus 1. What do you think the least common denominator of all three of these is going to be? X plus 1?
X plus
So that works for this, but that doesn't, this doesn't go into it. Okay, what? Okay, x plus 3 works here, but this doesn't go into it.
-6.
No.
X plus 1 in the middle.
We'll cut to the chase. If you see two parentheses, okay, it has to be at least two parentheses. Okay, so here's the deal. Doesn't x plus 3 go into this? Okay, and doesn't x plus 1 go into this? And doesn't this go into itself? This middle thing with two parentheses is your least common denominator. Because I can do something with this to get here, I can do something with this to get here. Okay, so kind of a thing to think about. If you see something like this, the one with two parentheses that shares both of the other denominators is probably your least common denominator. Let's write that down. LCD equals x plus 1 and x plus 3. Those two binomials multiplied together is the least common denominator. So let's think about it. What would I multiply x plus 3 by to get this? Like what's missing from here to get this middle one? Everybody, this is x plus 3. What is missing to give me this? X plus 1. So this first one needs to be multiplied by x plus 1 on the bottom and the top. So it's going to look like this. Same thing on the right side. What is x plus 1 missing to give me this middle term? Do you see how x plus 3 is missing over here? So on the top and the bottom, you're going to multiply by x plus 3. Now, real quick, do the denominators match? Are they all the same? So when they all match on the bottom, you can cut it out, slice them out. See you later. And then we're going to rewrite what's left over, okay? Now remember, you can distribute. What's x times x and what's x times 1? X times x is x squared, x times 1 is x. So again, x times x is x squared, x times 1, 1x. Bring down minus 6. 2 times x is 2x, 2 times 3 is 6. Okay?
Is it -6? That the only one?
Yeah, that minus 6 was right here.
That's what I'm saying. The next step.
Okay, so we'll talk about the next step in a second. I just want to make sure everyone's got this down, okay? Everyone's looking up here. Hey, in the back. Hey. I want everyone looking up here, okay? Because this is where things get weird, okay? All right? Here we go. Now, does everyone see that we have an x squared? Okay?
Yeah.
When there's an x squared and an x and a number like this is a situation where you can't just solve for x like we did on the front side of the page, okay? This is one of those weird situations. We're almost done. This is one of those weird situations where you're going to have to factor it, okay? So let me tell you, in this situation with an x squared, you need to make it equal 0, okay? I need to get rid of the whole right side. So how do I get rid of a positive 2x, and how do I get rid of a positive 6? So what's the opposite of a positive 2x? Negative. What's the opposite of a positive 6? Subtracting, yeah. So look at what we did here, okay? We are trying to get this equal to 0, so I'm going to try to eliminate the right side. Minus 2x, minus 6. And I get this trinomial, x squared minus 1x minus 12. I hope you, over the last week, think of something very specific. When you see something like this, what should you do to it? It's kind of like what we did, stop. It's kind of like what we did up here. What did we do this with this? We turned a trinomial into two binomials. It's called factoring. So what you should think about, everybody, when you see a trinomial is factor. Say it. Factor. 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 All right, so what are the factors of negative 12? 1 times negative 12. Negative 1 times 12. What about 2? 2 times negative 6. Negative 2 times 6. What about 3? 3 times what is 12? Okay, negative 4. Negative 3 times 4. Which one of those pairs is going to add up to make negative 1? What do y'all think? Which one of these pairs is going to add up to make negative 1? Negative 3 and 4 will make positive 1. So 3 and negative 4 add up to make negative 1. And now that we've factored it, if you remember when we did the notes for 5.0, you can solve this for each parentheses gets set equal to 0, and you solve it. And sometimes there are extraneous solutions that do not work when you plug them back into the equation. If you plug negative 3 into this, you get a 0 on the bottom. You cannot have a 0 on the bottom. Okay, so to make sure everyone has this down for real, and then we'll finish out the bottom with the fill-in part. I promise that's the last notes before spring break. Because next 2 days we'll just be knocking out assignments, ideally. Okay. Is anyone still getting these down? All right. By the way, this is not new. It just says negative 3 is an extraneous solution because if you add that, you get 0 on the bottom and you cannot divide by 0. Okay. So let's fill this out and that'll be good for these notes. So how do you solve a rational equation using the LCD? You find and cross out the common denominator. You solve for x, and an extraneous solution is a false solution that forces division by 0 in the original equation. Right? Once again, I want to limit the problems you have to do on here. Yes. So on these, you can just do number 1 through 12. You don't have to do the last two. All right, here we go.